Welcome to myprojectbazaar.com. Let me discuss about the process filtering image-based spam using multifactal analysis and active learning feedback-driven semi-supervised support vector machine. Let me discuss about the process filtering image-based spam using multifactorial analysis and active learning feedback-driven semi-supervised support vector machine. The identification of spam were more helpful in the networking since they consume a lot of bandwidth. The input images were classified as spam images or non-spam images by analyzing the texture of the images. The LPP patterns and gable features were more reliable pattern recognition tools. An image texture is a set of metrics calculated in image processing designed to qualify the precise texture of an image. Image texture gives us information about the spatial arrangement of color or intensities in an image or selected region of an image. Image textures can be artificially created or found in natural scenes captured in an image. Image textures are one way that can be used to help in segmentation or classification of images. To analyze an image texture in computer graphics, there are two ways to approach the issue: structural approach and statistical approach. The features were extracted based on the texture patterns extracted. The extracted values were saved. The system is initially trained with dataset images that contains spam and non-spam images. The trained features and the test features were given as input to the classifiers. The classifier classifies whether the input image is a spam image or not. The performance of the process is measured by measuring the accuracy of the process. Accuracy denotes the overall efficiency of the proposed system. Let us discuss the flow of the process. The input images were initially taken. It may be a spam image or a non-spam image. The images were initially update filtering. In the filtering process, two steps were followed: resizing and gray conversion. Resizing refers to the conversion of the image's size into a common for all the input images that we are selecting, and the gray conversion reduces the number of pixels in the overall images. The gray converted images were used for feature extraction methodologies. The features were extracted based on LBP and gable features. The LBP features extracts the texture-based information from the images based on the texture patterns identified in the images, which were exactly recognized by the shape analysis. Gable features were extracted from the images that represents the statistical parameters estimated during the orientations of the images, and the extracted values were combined and were then passed to the SVM classification methodology. So the SVM classifier classifies the input images into spam images or not spam images based on the training features available and the labels provided. And finally, the overall performance of the processes is measured using the SVM classifier, and the performance of the process when compared to the previous methods is improved. Let me discuss the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Main.m and main.fig were the main files where the other subfunctions were called. First, right click main.m and click on run file. You will get the user interface like this. You can select the images by clicking these buttons. So these are all the push buttons and we can select the images based on them. So in the data we have arranged the data based on spam and the non-spam images. Basically there are totally 30 images, 15 were identified as spam and the remaining 15 were identified as non-spam. So select any one of the images. The images were selected and they are loaded here, then we are pre-processing it. So as we said, the images were histogram of the input images, and then the images were resized and the gray conversion is applied, and after that LBB features were extracted for the images. These are all the extracted LBB features, and this is the recognized texture pattern from the input images. After that Gabor feature is extracted. So these are all the Gabor features obtained in the various iterations available. So totally for 12 iterations 24 features were obtained, and these are all the values displayed here. After that the spam detection process is employed. So the input images is identified to be a not spam image. Then the overall performance of the process is measured, and as we can see, this is the confusion matrix of the process, and it depicts about 98% accuracy, and this is the receiver operating curve, which depicts that there is small differences in the for achieving 100% results, and these are all the tables depicting the accuracy, sensitivity and the overall specificity of the classification process. So this process, the performance is measured overall for all the processes. So the images down below here are all not spam images. So when we give these images, let us see what happens. So the Gabor features were extracted. So while we detect, the images were detected as spam images. So the performance will be the same for all the processes since it is measured for completely the whole classifier. So the set of images were trained and they were used. So the process will be exact for the complete trained sequences, and for the other untrained sequences the results will not be so accurate, and it is like a 50-50 chance like that. Thank you.